Okay, these 2 pages right here, this one should get glued to to your journal. Okay, preferably with this strip at the top, so that when you cut this one to have these flaps, you will have this to go on the top of it, so that gravity won't make them flop all the time. Okay. You should have went between class. I need to get something. Get this glued in, and then we're still waiting on people. Okay. So cut these. Okay, so that you have 3 flaps. Okay. The scissors are all back here. I got a classroom set of scissors.
Alrighty, it's very nice productive back here. Nice variety. Excuse me.
So once you get the flaps cut on this piece, okay, then you're just taping it along here. Okay, you don't need to trim anymore or anything. You just need to glue it along the top there. Or tape it along the top. That will allow for you to have all of the steps that we're going to talk about today for graphing, solving with graphing. Okay. And then last week on Wednesday, we talked about solving with substitution. So if that you were unclear on your notes on how to do it, boys, if you're unclear on your notes, what your next step was, they're all written down here for you. So step by step. Okay. And then we've got the one for elimination, which is the same thing. If you got lost in your notes on what your next step was, well, here they are, all written down, step by step, what you're doing. Okay, for each of the 3 ways that we're solving. And then this calculator page just needs to go in there. I'm going to walk you through these steps, but this is a refresher, so you can go back and remember how to do it if you're needing to do it. And then this one is the one that you're going to be taking notes on today. Okay. So this one also needs to get put in your journal, but you may want to wait on it until after we get done doing all the graphs, because it's kind of hard sometimes to graph straight lines when it's already in your journal. Can I look at the restroom? Did you hear? Jordan, did you get to where you could? Okay. So up here at the top, to solve by graphing, find the point of intersection. What does the point of intersection mean?
When the lines intersect, like when they cross.
Where they cross, like the intersection of 2 roads, right? You call that intersection? That's what that is. Okay? So intersection. So up here on this clipboard, these blanks, a system of equations is a group of 2 or more equations with the same set of variables. They have to have the same set of variables so that they're talking about the same stuff. If they're not talking about the same stuff, then they can't be used to help each other or solve for each other. Okay, down at the bottom, this section on the same page.
I said, can I use the restroom?
When we're done with notes.
Well, that's the whole class.
Well, maybe we'll get to where that you can run really quick. Okay. So, how was the the videos last week? What did he tell you the graph of something that had no solution looked like?
They were parallel.
They were parallel. So no solution equals parallel, right? So draw you two parallel lines. They don't have to be exactly like mine, but draw you two parallel lines somewhere on that graph.
Parallel.
So they have no solution because they never intersect, right? They never intersect. Notice over here it says, if both lines have the same slope and different intercepts, they are parallel. Okay? So parallel is the same slope and different intercepts. Okay? Never intersect. Same slope, different intercepts.
What?
Okay, what does the infinite solutions look like?
Wait, infinite? Intersects.
Infinite, doesn't it keep going? Or is that different?
Okay, so
Jordan said it's on the same line.
it's the exact same line. Yep. So you've got two lines that actually are the same line. Okay? We call this collinear. Okay? Collinear. Down here it says, if they have the same slope and the same intercept, they are collinear. So same slope. So I'm actually going to put same line.
Oh, same.
Same slope. Same intercept.
Yeah, remember when Cutter recorded that girl? And she's like, oh yeah, get it.
Come on.
To the kid.
Abraham. What did graphs look like that had one solution?
That intersect.
They intersect where?
At the origin.
Not at the origin. We wouldn't have to solve for them if they always intersected at the origin. But they could intersect at the y-intercept. Could they intersect somewhere else too?
Yeah, the x-intercept.
No, they could intersect anywhere else. So draw two examples of lines that intersect anywhere. Okay. So these only intersect at one point.
Do we not get grades on our notes ever?
Yes, you do.
Because like, we spend a lot of class time on stuff.
They only intersect at one point.
See the white kid said, yo, stop real loud so the parents hear it.
That's what was at the top. For those of you that need to write that down really quick.
I didn't get that.
I go to sleep.
No, but you can take your hood off. So on the back here, okay, if they are in standard form, Desmos will let us graph them, right? Okay, but the calculators that we have in class that we're supposed to have locks down will not allow you to do that. Okay. So what is another way that you can graph these?
Use that one method, right?
Well, we could use a method we've already learned that would make this easier, right? Something eliminates right away, so you could use that. But if you're set on graphing it, or if you're being told that you have to graph it like this, okay, then remember you can use can a chimp blow a bubble? The answer is no, right? So this right here is your slope. Okay, and this one right here is my y-intercept. What's the first one? The C over A.
No, it's.
It's your x-intercept. And C over A is your x-intercept. So we're just going to use our y-intercepts and our slopes for these.
Is our quiz tomorrow?
Yep.
How many questions is it?
So y-intercept, I'm going to take C over B. So which letters are which? What am I talking about when I say C over B?
One. So.
Which one of these numbers is my C?
The 4.
Yes, if I were talking about that equation, but I'm talking about the top one.
8.
8, right? So A, B, C, they're in alphabetical order, right? So the first one. So C over B would be 8 over 2. What does 8 over 2 reduce to?
4.
And it's actually over negative 2. Don't forget the negative, right? So 8 over negative 2 is actually negative 4. Okay, so my y-intercept is going to be negative 4. Okay. My slope for this line is negative A over B. So negative 5 over negative 2. Does that reduce any?
No.
No, other than they could both be positive. If they're both negative, I might have to make them both positive. So can I go down 5 from this point?
No.
No, right? So I would need to make them both positive to go up 5. So 1, 2, 3, 4, 5, and positive 2 over. Okay.
No.
So be sure that you use your ruler that you were supposed to grab back here. Okay. Draw your line straight.
Yeah, sure, man.
Sit back down, Paul.
I'll get birth away, man.
Were you wasting tape earlier?
Where's my ruler, man?
Okay. Cutter, you have no business being over there when your seat's over here. We don't have time for goofing around. But your seat's right there. So you have no reason to run all the way up there. Okay, so second question. Y-intercept, or second equation. I'm also going to do something else. If we're color coding our lines, then put a dot beside them, whatever color you graphed it, or underline it, whatever color you graphed it. So right here, my y-intercept is C over what? The number in front of the y. So 4 over 2, which is 2. So I'm going to graph this line red. So positive 2 is my y-intercept. My slope, there's that invisible 1 in front right there, right? So negative 1 over 2. So down 1 over 2. Down 1 over 2. You only need 2 points to make a line, but when they're that close together, It's always a good idea if you can make another point, make it. Okay. So where do they cross? What is that point?
What?
What is that point, guys, where they crossed?
That is one, or that's two.
Well, it's two,
2 up 1.
2, 1. So the solution is 2, 1.
I hit it up on Snapchat.
So now to go down really quick. We're going to do this one next, and we're going to graph it on our calculator. Boys.
So what was the solution again?
All right. On your calculator, there's a couple of ways that you can get to a graph. You can hit the letter B to go to graph. You can mouse over and select this little graph picture. You can hit the flying calculator button, okay, twice if it's not already there. Okay, if you go back over to the calculator and you hit it again, it's going to take you to the graph. Okay. Now, this should come up at the top already. Okay. F1 of x equals. Remember at the beginning of the year when we talked about f of x equaling the same thing as y? So we're not going to change that when we graph our equation here. Our y is the same thing as f of x. The 1 is just saying that it's the first y that we're graphing, the first line that we're graphing. Okay? So we have a fraction. So how did I get that to look like a fraction?
Put it in.
Control and the divide sign, right?
Yep.
Gets it like a fraction. So 1/2 x minus 1.
Oh, that's the top of it. Okay.
Everybody should be doing this on their calculator with us. Hit enter.
Minus? Or is it minus
It's
one?
minus 1. You should get a line like this.
So it's going to be positive 2. And
If you can't tell where these are, okay, go to menu. Okay, well, you didn't follow directions at the beginning of class. It told you to clear it from the calculator.
Ooh.
So, right here on the view, so I'm at menu, and then I'm going to do view. And I want to see the grid. Okay, so you can go down to number 2, so you can see the grid. And then I prefer the dot grid, but if you want the lined grid, you can. The dot grid to me helps me see where the intersections are at, and the lined one is too busy on the calculator. So I'm going to select the dot one. So notice I can now see better where the coordinates are at on there. So I can see that my y-intercept for this line is at -1. Okay, and because my line on the calculator is blue, I'm also going to use blue for this line. Okay, and my x-intercept is +2. Okay. So now I can graph my line here. Now, to go back up, or if your line didn't look like this, hit tab if you need to edit. Okay, when you get the tab will pop this window back up again. Okay. If you need to go back and change something in this first one, you would arrow up. Okay? I don't need to change anything in that first one, so I'm going to go back to F2 of X because I want a second line to be graphed. Okay? I want my second line to be graphed, so I'm going to, am I going to type the Y equals in?
No.
No. Am I going to delete the F2 of X?
No.
No. Okay, so I'm just going to type in the rest of my equation there. I want it to look like a fraction, so 7 over 4 X plus, oh, it already graphed it because I hit the arrow over instead of the plus sign. So I need to go change it. So I'm going to hit tab and go back up and add 4. Notice that it displays the equations right here. So I know and I can look and make sure that I typed in what my equation should have been. So I'm going to use red for the second one because that's what color my calculator used. So can I tell what the y-intercept is?
Yeah.
Positive 4. Okay. What's another coordinate that I can use? It doesn't actually go through another coordinate till it crosses right there, right? Okay. So what is that coordinate? -4, -3. Okay. My lines are up. Okay, so what is my solution? -4, -3, yep. I'm going to show you something else while you have these on there. Okay, if you hit Control and the letter T, what pops up on the screen?
The table.
A table. So a couple of things. Okay. So notice that when I put my table up there, my equations kind of got jumbled up on top of each other. Right? If you use this little mouse pad that's on your calculator, okay, you can scroll over. If you see, get the hand button. I want to move this red one because it's on top of the blue one. So I'm going to hold down my mouse button until my hand clamps down. Look, now I can move it. And I'm going to move it up here to the top so that I can see it. Oops. And then click so it will stop wherever I moved it to. Okay, I can't see this blue one very well, so I'm going to clamp on it too and move it. Whoops. Okay, so this is one way. Lost my mouse trying to do it. That's on the screen. My hand is. Okay, notice my hand wasn't coming up, and it was because my box for my equation was up at the top. So over here on the table, and you should have this on yours. Notice that right here in this column, there's an X at the top. This is all your X values. This column right here is all your Y values for your blue line. Your blue line was the first line that we graphed. Okay? And all the red Y values for your red line is in the second. Okay? So notice I can scroll over so that I can see what my x value is and what my y values are for both of those. Here's when x is 2, my first one goes through 0. So at when x is 2, that's my x-intercept. Okay. I can scroll up. Okay. I can scroll up so that I can see other coordinates. Notice here, they're the same. -4, -3, and -3. So that's where that they're the same. And that's what my solution was right there. So that's one way, and that's one thing that this calculator will do. It will generate a table for you from the equations, whereas Desmos will not, without you putting in what you exactly want. Okay. Okay. So now I want you to do this next one on your calculator. Do that next one on your calculator and graph it.
I was taught to hold scissors by the handle when I'm walking. I know what I'm doing.
I forgot to tell you, Control T will also take it off if you don't want the table in there anymore. When you get it done on your calculator, it should look something like this. I should have everybody using their calculator right now with their head up. Cutter, come on. Jordan, did you get it done? You're not feeling well? You need to go see the nurse?
He's got to stay all day. Nah, bro, you can't say that. Okay, on that.
So you should have, your lines should look like this. Do your lines look like that? Then go ahead and get them graphed on your notes page. Remember, if you need coordinates, Control T will pull up the table so that you'll have coordinates.
Okay. What I do after that, Tuesday. Oh, it is Tuesday, huh? Yup.
Cutter, get your hood off, please. So what was your solution for this one? -1, 4.
Yeah.
That was the solution for both of them. So you should have a line that goes
Mama wants it, he tell you what.
So you should have one that goes this way, goes through -1, 4, and 3, 0. And then you should have one that also goes through -1, 4, and goes through negative or 0, -2. Sorry, wait. 0, -2.
What does it mean when somebody says you can fill up the pot?
So up here on this one, we can rearrange this to put it in standard, slope-intercept form to solve. Get that in slope-intercept form. We can use, can a chimp blow a bubble again for that one? What type of a line is y equals -4 going to give us? It's going to give you a line that crosses the y at -4. Yes. This other one, okay, you can't graph that one on here. You can graph it on Desmos. Okay. But if we rearrange it, okay, if I subtract 3x from both sides, okay, that gives me 2y equals -3x plus 4. Divide everything by 2. This is what it means by solving it. So -3/2 x. 4 divided by 2 is 2. So now I have my other line. Okay, so it goes through +2, goes down 3 over 2, down 3 over 2. So there's my solution for this one. Okay. So my solution is right there, which is at 4, -4. Okay. Here in the middle, some advantages for doing this is that if you like graphing, this is easy, right?
Yeah.
Okay, if you like to graph, then this can be easy. Okay, there's little algebra needed. Right, so that's one advantage. Okay, especially if it's in slope-intercept form, right? The other advantage is you get to see a visual solution. Some disadvantages, however, are that sometimes it's harder to get an exact answer. Integer answer. If it doesn't end up exactly on a coordinate. Okay? You must be accurate in your drawing. Okay? And one other disadvantage, if you have room there, is that if it has large numbers, then it's harder to graph on little graphs. Okay, if these numbers were like 16 and 20, we would have a hard time graphing it on our graph that only counts to 5, right, on each side. Okay. So your assignment is this one. Okay, now hang on, listen, okay? These on this page need to be graphed. That is our lesson today, was graphing. So you have to graph these. You have to have 2 points. The lines have to go completely through the graph. This page right here is also, I'm not done talking. This page right here is also your assignment. Okay, gives you more practice on substitution and elimination before tomorrow's quiz. Boys, this last page right here, I did not tell you to put stuff up yet. So this last page right here is all bonus for the quiz tomorrow. So you can earn 3 points for each additional problem that you do here that's correct and done completely. So that's 15 possible bonus points for your quiz tomorrow. Okay, that's the last page. It tells you at the top. Okay? You can only do one of them by graphing though, because there's only one graph given. So if you want the bonus points, you have to show your work.